Hello QCon Plus. Today I will be presenting Unwinding a Decade of Assumptions, Architecting New Experiences. I love puzzles. This is one of my favorite puzzles because it's one of my favorite shows. It depicts a group of bank robbers celebrating their big score. There was just one problem with this puzzle. When we pulled it out of the box, I found that the edges, it was hard to see where the pieces would go. And the contrast, it was hard to see the differences between colors. And so this was a really hard puzzle to look at. And even in the best light, I found myself having trouble putting it together. This is a lot like working in microservices. When you work on a service, you know how your service fits with another service, but it can be hard to see the bigger picture. Hi, my name is Cole Turner, and I'm a senior software engineer at Netflix. I build client-side applications for the non-member website, which is where our customers go when they are logged out or don't have an account. A lot of the work that I do is building UIs that interface with upstream microservices. And so in my experience, I've seen this interaction between how microservices work together. Now, before we get started, I'm going to briefly describe what a microservice is so that we're all on the same page. When we arrange our application into loosely coupled components, developers have more leverage. We have a client that talks to our API or edge, which is responsible for creating all of the data that the client needs by talking to microservices. These services can depend on each other or operate independently. Services are often designed around modular functionality or business domains. And it's no secret that at Netflix, we love microservices. They are a fundamental part of our architecture, allowing us to operate and scale globally in the cloud. They're crucial to our business, where we seek to entertain the world, reaching billions of people. And a lot of you know that Netflix was an early pioneer of microservices, but it first began as a Java monolith when we built our website for DVD in 1998. When the application was deployed, all of the libraries across all of the engineering teams were pulled together, built, and deployed in one go. This would take a lot of time, and the biggest problem with this is if there was any issues with just one of those libraries, that meant all of the engineering teams were responsible to be on alert and investigate the issue. In 2009, our engineering teams set out for the migration to microservices. It began with our non-customer facing parts of Netflix, and then later our consumer product. Over the next few years, Netflix would also carve out its Edge API, which is where our clients talk through the gateway to upstream microservices. This division between microservices allowed all of our engineering teams to focus on what matters most, what they're good at, and what their workload is. The diagram you're seeing here represents the flow of requests from the client through our gateways to upstream microservices. As requests come in from clients, they pass through our routing and API tiers and onward up to the services. So now I'm going to talk about what a microservice looks like in Netflix. Our microservices are made up of a client library, a persistence layer, and a cache layer. When a request comes in through REST or gRPC, it will use either one of the service client or the cache client to fetch data. The cache client will pull from one of our EV cache stores, which is a Netflix open source solution for distributed in-memory cache. If the data is found there, then it will return from there. But if not, then it'll use the service client to pull from a persistence data store, such as MySQL, Cassandra, etc. This combination of cache and persistent layer allows our services to scale to thousands of requests per second. That's a lot. And now I'm going to tell you a story about the hidden cost of simple assumptions when it comes to microservice architecture. In 2019, we unveiled a new user experience where visitors coming to Netflix.com could watch free content. We wanted them to be able to watch from a limited selection of select shows right on their mobile device. They would be able to watch from their browser without having to download the Netflix app. But here's the catch. The users would not be asked to log in or sign up for an account. They'd be able to watch free content without even having to provide an email address or selecting a plan. This was 15 years of Netflix history that we were trying to unravel. We unlocked DRM-protected playback for non-members without an account. We enabled playback on mobile web browsers for the first time. And we did all of this without having to rebuild our entire microservice architecture. It sounds easy, right? Just flip a switch and allow non-members the ability to do what our members have been doing for over a decade. On the surface, it sounds like a few lines of code, a piece of cake. We knew going into this project that our back-end teams, were built around members and subscription plans, and that we knew we would have to change that, or at least confront it. But before we could do that, we needed some answers. We needed to understand how all the pieces fit together. Playback has always been a member feature, and this was the first time that our non-member teams needed that domain knowledge. And we knew that this was going to be a significant effort, but what we didn't know was the assumptions we were making about the level of effort and the impact that it would have on our back-end teams. And lastly, we needed to know which teams to talk to. We needed to know, are we doing the right thing? Who is this going to impact? And what I love about Netflix is that our culture embodies this highly aligned, loosely coupled teams that collaborate well together. Our product and engineering teams are amazing at collaboration because we socialize on what we're trying to do. So now that we had our answers, it was time to get to work. At a high level, the puzzle pieces looked like this. Our UI and streaming client would talk through the gateway to the Play API orchestration layer. And to allow non-members, we needed to coordinate with those engineering teams. So we partnered with them, and for months we worked on orchestrating the non-member, getting playback to work. And while this isn't everybody who was involved in the project, we worked diligently with our other microservice teams to make this all work. And now I want to tell you about the biggest challenge that we faced. Many of our services upstream had this built-in assumption that anytime they would be called, there would always be a user object. That's because for the longest time, they were only ever called with a user object. These assumptions were prolific and one of the most challenging for our team to address because we're dealing with non-members, and non-members aren't logged in. And if they're not logged in, there is no user object. So our team started working together to figure out how to get around this problem. We looked at several options. The first option that we looked at was, could we create a user for every non-member coming to the website? This would prove to be expensive because we expect high volumes of non-member traffic, and it would be wasteful because the account would only last as long as their browser's session. And so we needed to explore other options. The second option was, could we work with the services to provide support for non-members? Would they be able to support if there is a user object or not? But this was also expensive because it would take them months, if not years, to build support for this. And that's a risk because while we're trying to get something out the door, this would delay our project. This would delay us years. And so we had to look at another option. So the third option that we looked at was, would we be able to fake it? Could we mock a user object with a non-member? We liked this solution because it's easier, it takes less work, and it's a good shortcut that would hold us over while the long-term strategy is planned out. This was the option that we felt was best for us because between the options, it would allow us to get our feature out the door. So we looked at how we would make this option work. When a client makes a request through the gateway, The service call contains a context object to identify the user and their device. The request then goes through the playback API orchestration layer, where it talks to subscriber for the source of truth. This source of truth tells us whether or not the user is eligible for playback based on their account and device settings. But what if there is no user? And so our playback API team started to mock the non-member user, which meant that they no longer needed to call the subscriber microservice. By mocking the user, the Play API orchestration layer would be able to fulfill all of the requirements to meet the playback lifecycle. One outcome to this option was that now this would be the terminal stop for non-members in the service call. This would reduce the pressure of requests on upstream services. Another outcome, which is my favorite, is that those teams would no longer need to do any work on their side for us to get our experiment out the door. This would hold us over for the short term, and we like this, but we really were hungry for a more long-term solution. And so we started to think about how users would access Netflix in the future. In 2020, our access and identity management team set out to unwind these assumptions and look for a more long-term solution. They partnered with engineering and product teams across the company to align on a vision for how we think about users accessing Netflix. As a result, we all came to the conclusion that we needed more leverage to control user friction with granularity and more flexibility. Since then, they've set out to refine our access control strategy. We started by looking at what strategies we already had in place. Our primary strategy for access control was a role-based strategy. Our role-based strategy has largely revolved around whether or not the user is a member and has an active subscription plan. When a user tries to play back, our services are checking these things and deciding whether or not they are eligible. This strategy works well when the user experience has very clear boundaries across very clear role types. This kind of strategy is easy to use because it doesn't require a lot of complexity across your services. However, it's harder to scale because as the number of access points increase, as the number of roles increase, there is a lot of ambiguity and a lot of work to be done. At Netflix, we found that this role-based strategy was hard for us to scale to do the kind of user experience and learnings that we wanted to do, so we needed to explore another strategy. We started looking at attribute-based access control. This strategy is one where the permissions are contextually aware and can take in factors from multiple sources, such as who is the user, what are they trying to access, how are they trying to access it, and what environment are they in. Let's look at an example. In this example, we have a permission of whether or not the user can play back. This permission leverages several properties about the user, such as do they have an account, do they have a subscription plan, which device are they trying to access from, and where in the world are they. And what's nice about this strategy is if we wanted to evolve this permission, we can take into account other factors, such as expanding the policy to include A/B allocations, or any other factor that we can model in our backend. And when we compare these two strategies side by side, there are a lot of reasons to prefer attribute-based access control. This strategy provides more granularity, which gives us more leverage over user friction. This strategy gives us more flexibility that if we want to come up with new ideas or implement new permissions, we don't have to do a lot of work. And moreover, this strategy gives us the ability to scale better because rather than making a change across our entire architecture, we can make a change just in one service. On the other hand, if your user experience only has a limited number of access points or a limited number of roles, then a role-based access control strategy is still an excellent choice because of the simplicity it provides. Looking back at our experiment, we would have avoided a lot of time and heartache with an attribute-based access control strategy. With permissions, our Play API can fetch from the permission service to determine if the user is eligible. The permission service will look at the request context, such as who is the user, which device they're trying to access from, and any other number of factors. It can also pull information from other services. It will then cache and return the result back, and now we know whether or not the user is eligible. However, there are times where we want to show more friction or add some extra steps when the permission is denied. A good example is when your kids are logged into Netflix and you don't want them to accidentally spend more of your money on a more expensive plan. When our permission service is getting requests from hundreds of services and UIs, we want to make sure that it doesn't become a single point of failure and take all of Netflix down. Our teams have thoughtfully leveraged multiple strategies to make sure that doesn't happen, including caching and fallbacks, as well as standard practices of scaling, availability, and performance. All of this really excites me because I see how it sets our teams up for success. When we have a single service governing access control, then our source of truth becomes centralized instead of distributed. And when we use attributes for access control, then we have more leverage to control user friction with more granularity and flexibility. This lets us tailor our user experiences and really try out new things with ease. This feels like the future to me. I would call this the future of microservice permissions because this model lets us scale our efforts, and we can rapidly experiment and learn how to deliver the most exceptional experiences for our customers. And with all of that said, I want to talk about one assumption we often make about microservices. You only ever hear people talk about how good it is and how it speeds up innovation. But that's not always true. It would have taken a great deal of time and effort for us to have done this all before our experiment. We would have had to gather all of the engineering teams, assemble, share context, agree on timeframes and milestones, and then that's before we even get into development. Even developing it would have taken years. And so we optimized our plan for what we could do in the short term. While our teams were invested in a long-term strategy, we had to get something out the door. And then we would follow up with a long-term solution. The message here is that we need to plan ahead and that our technical problems are not always embedded in technical solutions. There are always non-technical dimensions here. And now I would like to leave you with 3 key takeaways. The first takeaway is that assumptions are natural, and it's our job to unwind them together. We need to collaborate and gather all of our stakeholders. We need to ask ourselves who needs to be involved in the discussion and who is missing from the conversation. This way we make sure we're gathering enough context, but also we know which solutions exist already and which ones don't. This will also inform us what is going to be the level of effort so that we can evaluate the trade-offs and make the best decision. All of you can be facilitators in this process. The second key takeaway I want to talk about is we need to invest in long-term strategies that can be paid off over time. It's not enough just to solve this one problem, but we need to anticipate how this might snowball or how this solution will continue to evolve as our needs evolve. Because the conversation will continue and our customers will come back with additional requests, and we want to make sure that this works for the long term. This will also help us with our next key takeaway. Our third key takeaway is that we need to size our efforts by risk and reward. A long-term strategy is great, but we need to get something out there because we can't spend forever trying to work on the best, most ideal solution because we might never get there. Priorities change, businesses have new needs, or maybe you're in a company where you're running out of money. And so you want to make sure that you're sizing your efforts by what can we get done today and what will pay off. and then invest in those long-term strategies. The last thought I'll leave you with is that the difference between programming and engineering is vastly different. Programming is just writing code and solving problems, but engineering is all of the collaboration and communication that happens to make us more effective in doing that. Because engineering is about bringing the group together so that we're all on the same page and we're doing the right thing for what's best for our business. And when we do this, we pursue the non-technical realm. We're talking to people, we're engaging, we're having a good time while we're doing it, because that is what makes us better engineers. Thank you all for joining and listening. I really hope you enjoyed hearing me talk about microservices and assumptions. If you want to hear more from me, you can follow me on Twitter at Cole Turner. And I hope you enjoy the rest of the presentations at QCon.
Thank you so much, Cole. It was great to have you, and thank you so much for the talk. I'm sure everybody really enjoyed that. So there's quite a few questions which have come up in the chat. So I think let's dive maybe into some of those. So there's quite a few, so I'm going to try and kind of group things. But if we don't get to all of them, I think we can hang out in the Hangout session, and I'm sure you can answer people there as well. So maybe one of the questions which came up is around the sort of RBAC ABAC thing. So one of the questions was, how much time did it actually take to overhaul this sort of authentication move from role-based access control to attribute-based? And I'll probably throw another sort of question in there, which is, what kind of challenges did you find kind of moving between those two? Was it sort of easy, or what was the challenges there?
Oh, great question. So, when you're faced with such a large change and, you're dealing with all of these assumptions that are baked into your microservices, the biggest challenge is you want to get everything done at once, but, businesses have many needs and priorities. So we really have to strategize what can we get done today and what can we pay off over time, which kind of the major theme is we really want to, make sure this works. So we will start with some small initiatives that we think will kind of leverage this new system, this new architecture, and in this case, the new permission service. And by testing that out, we suss out, the performance, the scalability, the availability before we start to implement this across all of our systems. And it is still an ongoing effort. Our access and identity management team, they're amazing, and they've planned out a multi-year strategy to integrate the permission service throughout our Netflix architecture. And this will include the consumer product as well as, how the different users will access Netflix.com.
Mm-hmm. So I guess that means you're not finished with the migration yet from RBAC to ABAC. It's still in process, and it sounds like it's been going on for a year, months, a while.
It began about a year ago, and
Okay.
as we have new initiatives, as Netflix continues to reinvent itself, they're continuing that migration or integration.
Excellent. All right. So a few questions around some of the sort of technologies and things in Netflix. So what kind of standardization does Netflix follow across microservices? Is there any kind of standard tooling and or approaches that are followed the way you kind of do things? Or what kind of standardization exists?
Yeah, great question. We have a platform team that provides us with it's a toolkit for creating applications and services at Netflix. And this toolkit contains various blueprints for common application types. So whether you're starting a Java application or a Node application, a client or a service, the platform provides common infrastructure for developers to kind of follow a paved path. And really, this is about providing the best outcome. Our culture at Netflix embodies freedom and responsibility. So our teams are free to choose any application type or, invent their own. They may decide that they find one technology really suits their needs, so they're free to pick that and prove it out.
Mhm. Okay. All right. So let's see. Can you mention something about your caching strategy for user permissions? So you spoke about how you kind of cached some of the permissions there, and maybe how you deal with invalidated tokens for users who have logged out if there's no sort of centralized server.
Great question. So it's kind of two questions. When it comes to caching, we have our standard practices of availability, scalability, and performance. Having multiple instances, having multiple cache instances. From the talk, most folks saw that the client library will first check from the EV cache before it actually fetches from the permission service, which is the kind of primary, throttle for preventing too much load onto the permission service. However, please correct me if I misunderstood the second question. It is how do we handle invalidation for tokens for non-members?
I guess the invalidation, so it says specifically dealing with invalidated tokens for users who have logged out.
I see. So we have different strategies for how we treat our logged in users versus how we treat our logged out users. They rely on two different kinds of tokens at Netflix. And if you want to know more about that, we're hiring. But what I can say is, in addition to that, we also leverage cache expiry times to make sure that whatever permissions we do give to a user, they live in a cache, but only for a certain length of time. And that length of time can be customized to each individual permission.
Mm-hmm. So do you do explicit cache invalidation, or you pretty much wait for the timeouts to occur?
I believe it's a combination of both, but I'm not too familiar with that area, but I know that we leverage expiry, and I'd have to say that I'm not too sure on the invalidation manually, but if it were me and I was in that position, I would assume we would.
Fair enough. All right, excellent. So another question that we got was, how do you scope your microservices? What kind of principles do you use for figuring out what belongs in a microservice? Because we hear a lot about domain-driven design and various different ways to put things together. How do you guys work out what goes in a microservice and what doesn't?
Yeah, it's a great question. When I look at all of the microservices we have today, a large part of how they are divided is by business domain. So which services serve the consumer-facing product, which services serve our studio, or some of the services behind the scenes that delivers great content in front of users. However, sometimes a service becomes so big that teams decide, well, how we treat this functionality is not how we would want to treat this functionality. So they decide to break it up, and they might create even smaller services. And this revolves around the modular functionality of each, piece of feature. So, we have services for videos and different kinds of videos, artwork, as well as metadata. And so we do tend to follow the modular functionality or domain area.
Mm-hmm. So it sounds like there's a combination of, I guess, the domain-driven areas that are in particular domains will be in certain microservices, but at the same time, you've got specific technical reasons for why you might choose to put a microservice by itself. Maybe it needs to scale more or something like that. I'm guessing there's various reasons around that. Okay.
Exactly.
Fantastic. So there's so many. I'm not sure we're going to get through them all, and I can't read fast enough. So apologies if I don't. There's so many questions. I'll pick a few, and we can do the rest in the next chat. All right. So what kind of, I think you've answered this, technologies, languages, and frameworks are used by Netflix, which I think you've said every team is kind of free to use their own, but you do have a lot of libraries and stuff that you have actually built with Netflix. So, I mean, if people wanted to learn more about the Netflix microservice architecture, where could they go to find out about some of the stuff that you guys are doing?
Oh, if you're interested in learning more about Netflix architecture or any of the technologies that we leverage at Netflix, there are two destinations that I highly recommend. We have the Netflix technology blog, where you will hear from our service teams, our data scientists, front end, back end. All of our teams at Netflix are welcome to publish at this blog, and it's actually where I myself have learned a lot about our architecture and how our services work together. Moreover, you can also check out the Netflix open source GitHub, where you will find many of the solutions that we've open sourced for our architecture from when we moved to microservices. So you'll find open source repositories like Eureka, Hystrix, as well as anything that we have open source that we have found to help us, deliver exceptional user experiences.
Fantastic. All right. So let's see. So there was a question around testing, which let's see if I can find it. I mean, there were a lot of changes when you, especially when you kind of moved from your R back to A back. How did you go about actually testing these changes, given that there could be so many sort of wide-ranging implications of where things could kind of go wrong? How does the testing work?
Ooh, I love this question. I tend to think about the technical versus the non-technical. When we look at the technical, there's obvious things like automation and alerting and monitoring. And so we have a lot of observability into both the life cycle of how our users are enjoying Netflix, as well as how our systems are handling all of these users. And then there's the non-technical components, which are, we have so many people interested in projects, or we collaborate very well across cross-functional stakeholders, that there are always a lot of eyes on what we're building. And there have been times where I'll hear some feedback from somebody across product, and we'll figure it out and we'll adjust from there. So it's definitely, it's a lot of collaboration.
A lot of collaboration. Fair enough. Have you got sort of, I guess you've got quite a lot of automated test suites and things on services, but you can't test everything because there's so many. Do you have any kind of strategies as to what you test versus what you don't in an automated way?
Ooh, excellent question. So we employ different automation strategies across the stack. We, across all of our backend, middle tier, and client applications, each layer is doing its own level of testing to make sure that the integration works. And if you look more towards the client side of the stack, we often write user story focused automation to make sure that what we expect for our customers to be able to do, as well as not to be able to do, that's the kind of automation that we're writing, as well as we try to strategize making sure that this experience translates cross-platform. So our clients will be writing, automation for our website, for our mobile apps, for our TV, as well as different devices. So we have a mobile automation lab, which Netflix engineers can run automation on various devices. So for an experience like the one that we launched, we made sure that we were running our automation across a large variety of devices to make sure that the user experience was consistent from device to device.
Mm-hmm. Great. All right. Okay, let's see. Probably got one more question, and then we'll have to move into the next section. So maybe just a quick one. What is your API gateway layer? The sort of technology that's used there, is that Zool still, or is it Amazon stuff? What is the actual technology used for the API gateway?
This is a very, very big question, and I will try to answer as much as I know from my side of things. But if you want to learn more, please check out our job site and talk to our other engineers. But our API gateway layer is a combination of we call it edge, and it's basically the edge of the client. So it's the routing, it's the anything in the middle tier that handles authentication, request context. And so we have various API edges that service our different um, Netflix domains. So, the core product has its own edge, the studio has its own edge, as well as other parts of Netflix. And the technologies that we leverage include, I believe, Zool might be open sourced, which is our sort of router. And then you have other technologies that power like the service to service communication. So Eureka being one of those, Hystrix. And then the edges will talk to the upstream microservices through REST or gRPC.
All right. Well, thank you so much, Cole. That was great, and it's time to wrap up now. There are so many questions, so I suspect there will be a lot of people wanting to speak to you in the Hangout room. So please do join us there, and Cole will be able to answer hopefully many more of your questions. So thank you so much.